Hey everyone, welcome to my YouTube channel Computer Vision, AI and Robotics World. In the previous video, I have given you the introduction about this channel, and in this video, we are going to start a new lecture series called Computer Vision. So in this video, we will get some introduction about the computer vision, some history how the emergence of computer vision took place, and what are the current researches that is going in this field. So to start with, let us first understand what computer vision is. Basically, computer vision is an area of artificial intelligence which gives the computer an ability to see, understand the virtual world from digital images and videos. The history of computer vision is very old. So this started in 1960 to 1970, where the researchers were trying to understand what is blocks, edges, and how they can fit the early neural network models. Then they switched in the next decade from 1970 to 1981 to the low-level vision such as stereo, flow from X. In 1985 to 1988, people started working in neural network, backpropagation and self-driving car. Although self-driving car did not existed during that time, but people had some idea about this and they were trying to solve the problems around this. In 1990 to 2000, there was like a dense stereo that came in. Then there was a multi-view stereo. Then scientists also started discovering Markov radiance field. From 2000 to 2010, they majorly focused on features, descriptors, and structure from motion. From 2010 to even today, people are exploring deep learning because of the growing data set, and that has actually led to the rapid growth in this field. So because GPU and new data center has came in, this field is actually one of the major field where a lot of advancement is taking every day. So there is one of the famous problems that scientists started solving was like a problem of stereo. It is also called photogrammetry. So this problem was first brought by Gilbert Hobrow. So what he suggested that, for example, if I am going through a plane and I see a field, if I take a picture from a plane and take the picture of the field from the plane, then can I understand the depth of that image? And this problem actually took the attention of lot of researchers at that time. Then came Rosenblatt, and he came up with a new idea of like early neural networks. That was very simplified neural network, and it was used for binary classification majorly. Then people thought of solving some problems of blocks. For example, if we have a 3D image that has some edges, some vertices, and can we draw some 2D reconstruction lines from those images? And this was what the problem was about. Then in 1979, Fukushima, he was one of the Japanese researchers, came up with the idea that was inspired from the visual cortex in the brain. So he introduced the concept of hierarchical layer for pattern recognition, and this was further evolved in CNN. So if you see that the structure of knee cognitron structure, it has like two cells. One was like simple cell, another one was a complex cells. So the simple cell used to act like a feature detector. So you can consider this as a filters that we have in our current convolutional neural network. This cell has like the complex cell that I'm talking about right now has like translation invariance feature. For that means that if there is any shift, a small shift in the image, then also the feature does not differ, and this was actually being replaced in the CNN by pooling layers that we have. It can either be a maximum pooling or an average pooling. Uh, to all the viewers, if you are very new to the field of computer vision and you are feeling that whatever I'm going to talk through is very difficult for you, then please don't lose the patience. In this video, I'm just talking about what are the major researches that has taken place. But in the coming video, I will explain lot of things from this topic, and if you come back, probably you will understand it, and that will also help you to read the research papers that was being published in these fields. Then the forward propagation was always there, but people wanted to know a right way to optimize their weight. Then back propagation came in, and it has actually solved lot of problems. Neural network was used for digit recognition, and it was being shown by Leque and other scientists. In 1990, this decade, most of the researchers focused on geometry. So there were a lot of geometry based research paper that came during that time. For example, fundamental metrics, normalized 8-point algorithm, then random sample consensus. So this random sample consensus was actually a very robust computer vision technique that was used for motion estimation and 3D reconstruction and model fitting. Then people came up with another problem in computer vision that is called template tracking. So what happens is, if you have a football player and you are taking a video of a football player and he's like moving from one place to another and you want to track this. So what researchers do, they create a template of this football player, and from that template they track where this researcher is moving and try to match the template in each of the frames of the video. And that's how this template matching used to work. This template tracking was good, but the major disadvantage was that you can only track one point at a time. Then people wanted to understand how the pixel flow in a image. So then this lead to the discovery of optical flow. So the pattern of the apparent motions is very difficult to find. So what they do is, like, they are densely tracking the pixels between the frames. And one of the famous algorithm was Horn-Skunk algorithm. So what they do, they try to see what is the gradient of each pixel from one frame to the other frame. Then in this optical flow, FlowNet has become very famous because it was based on convolutional neural network. Although for years people realized that this deep learning plus optical flow is like very good for motion estimation, and like the classical point tracking methods like surf matching were like very outdated. But recently, if you go and read some of the famous conference paper like the CVPR paper, you will see that like point tracking has started becoming famous again, and now people have becoming researching this again, and they think that it can be actually helpful in long term tracking. If you see the recent application of augmented reality, virtual reality, robotics, then you will understand that these application basically supports the point tracking instead of tracking the pixels from one frame to other. So what does this point tracking means? So as I've already explained you, what does it mean is, like, it sort of takes some points. For example, take some corner feature across video frames, and then you started tracking where it goes. But in optical flow, what happens is you take a dense of all pixels and then you track them. That's how this is. So if you see the current point tracking techniques, then we have like TAPNet, and in optical flow we have RAFT. Then in 1970, there was one more interesting application that came into picture, that was understanding the shape of an image from its shading. So what they do is, from the 3D, they want to understand what is a 2D single image. So this was actually based on an assumption that there is like simple lightning and there is a material which is also known as Lambert with constant albedo. We will understand all these assumptions in our later chapters. Then we have like intrinsic images. So what intrinsic images stands for is that images can be decomposed into the lightning properties. For example, reflectance, shading, shape, and motion. So it was actually helpful for downstreaming tasks. For example, if you remove the lightning, you can actually be able to understand what is the object detection. It can be helpful for you to detect an object. Then we came with a photometric stereo, where you wanted to understand the surface orientation from multiple images. It helps you to recover 3D from multiple 2D images with varying lighting. Then we have like structure from motion. So this structure from motion is also one of the very famous and interesting field of research in the community of computer vision. So what does it stands for? For example, if you have an image of a house and you set up multiple cameras at different lighting angle, and what you do is, you from each of these images you try to understand or try to construct the 3D structure from these static images. Then we have like some of the research that went around like iterative closest point. Then there was like a multi-view stereo where you 3D what you do is you do a 3D reconstruction from multiple images. And then in 2024, DUST 3R does 3R 3D reconstruction as supervised learning. So what this paper came in CVPR conference, and it is one of the famous discovery in this community. Is like what it did was, like, instead of geometric optimization or learning to predict this 3D cloud point directly from image pair, what you do is you train lot of larger data sets, and then you compare it with a ground truth 3D geometry of it. So what that makes it DUST3R as a data driven model instead of purely geometric based model. Then in 2000, people started understanding some properties of camera. So what they did was, like, they placed many synchronized camera to capture a scene from a many different angles simultaneously to understand how does it look like. And in film or in movie, The Matrix is one of the greatest example. In 2020, many of the researchers started studying about the neural fields and the neural implications. So right now we have all the 3D representation of any image as a discrete set, but now they are trying to understand it from a different point of view. So like, for example, from meshes, point cloud, or voxel codes like 3D cubes. But these are very very memory heavy. This voxel code is very memory heavy. So the core idea was, like, instead of storing the 3D geometry explicitly, you represent it as a continuous function, and this continuous function can be generated from a neural network. So once you get this continuous function of an image, you can actually get to understand the different properties of the image. For example, distance to the surface, density, color, etc. Then continuation of that field, we have like neural radiance field. This is same where you have image collection and you learn the mapping of this XYZ to color and occupancy. This is one of the recent research research that many of these scientists in this field are exploring. Then in 2024, people started working in Gaussian splatting. So the intuition was, then when you cast a ray from just one pixel, then it is just a waste of time, because the one pixel cannot give you much of the information. But when you actually represent it as a collection of points with 3D Gaussian, then it can actually helpful to understand the image plane and can be helpful to infer the 2D Gaussian from the 3D Gaussian. And the advantage was that it can actually help you to save time and memory of the object. Then we have some generative model that came into it, like variational encoder, GAN, diffusion, video generative models. But after going through the history, you guys might be wondering that is vision is a collection of tasks. So collection of tasks such as image segmentation, 3D reconstruction, novel view synthesis, video generation or point tracking and many more. But is the vision is like about this? Vision is not that thing. Vision is actually modeling the world and yourself within it. So the vision can be more than what you think right now. Vision is actually an ability of an agent to build dynamic model of its environment by perceiving it through its senses. This is actually one of the famous definition that was being given by Winston Sitzman. He's one of the professor in MIT and he teaches a lecture of advanced computer vision modeling. And from his lecture, I get this beautiful definition of what vision is all about. So vision is like, planning and having an intelligent solution out of it. So what a scientific community calls a task. So basically a scientific community identifies anything that is solvable problem, that is the task for them. So with this, let me end this lecture. Thank you so much for listening to this lecture. In next lecture, we will try to understand our first module of the computer vision. Till then, bye. Please stay tuned to my channel.